Alright, and I just wanted to illustrate one more problem that has a little bit of a curveball to it. Again, we're going to start this off by squaring both sides, but the key is you're squaring this entire term on the right-hand side. So this is going to be expanded out into a polynomial. So now we've got 2x plus 1, and that's going to equal this x minus 7 squared, which if we kind of write out over to the side, I have to work out this multiplication. So I've got x times x, which is x squared, x times negative 7, which is a negative 7x, negative 7 times x, which is another negative 7x, and then negative 7 times negative 7, which is a positive 49. Okay, so now from here, I'm going to start combining terms together and solving. So I've got, on this side, I've got x squared minus 14x plus 49. All right, and I want to manipulate and change things here so that the stuff on this side of the equation, I don't want anything left over here because I'm dealing with a quadratic equation, so I want to set it equal to 0 so that I can either use the quadratic formula or factor, depending on what you guys are familiar with and have used before. So if I subtract 2x from both sides, that will leave me with x squared minus 16x plus 49, and then that's all going to equal 1. And then I'm going to subtract this 1 as well. So now I have 0 equals x squared minus 16x minus 48. I'm sorry, plus 48. Silly me. All right, so I'm going to factor this expression down here.
That means we think that you could.
And I'm going to do that. Again, I want this negative 16x in the middle. So I need to ask myself what factors, come on, work, thank you. What factors will give me a negative 16x in the middle, but will multiply together and give me a positive 48? So if I think about it, the factors 12 and 4, if I multiply those together, I get 48, and if I make them both negative, then it'll give me a positive 48 when I multiply them together, and a negative 16x in the middle when I add them. So these are the two factors that may lead us to a solution for this system. So I'm going to set each one of these individually equal to 0, and solve for x. So I've got one solution of x equals 12, and then doing it again. Adding 4 to both sides. So I've got a solution possibly of x equals 4. And I say possibly because you do need to go in and check these to make sure that they work. Meaning that some of these solutions may lead you to a negative answer, which won't work in the formula. So if we plug these in to our original equation here, we just need to check and make sure that both of these solutions will work in the term underneath the radical. So if you test them both out, you can see you'd have 2 times 12, which is 24, plus 1, which gives us 25. That one clearly works. If you do the same thing here, oh, actually, there's a little more that we need to test than that, and I need more space, so I have to erase this here. In other words, what I'm trying to get at is that occasionally you will get a solution that hypothetically will work, but either the signs won't work or you'd end up with a negative number underneath the radical, so you do need to test these and check and make sure that they will work. So again, our original equation was just the square root of 2x plus 1 equals x minus 7. So I just want to check and make sure that both of these solutions work in this problem. So if I plug in 2 times 12 plus 1, I'm going to check and make sure that that works out to what it's supposed to be. So I've got 2 times 12, which is 24, plus 1. That gives us the square root of 25 on this side, and 12 minus 7, which is 5. And clearly the square root of 25 is 5. So 12 works. Now we need to also test the 4. So I think I can write small enough over here. So I've got 2 times 4 plus 1 underneath the radical, and 4 minus 7 on the other side. So that gives me 2 times 4, which is 8, plus 1. That gives me the square root of 9 equals, and 4 minus 7 is negative 3. So here's the problem, is now the square root of 9 is positive 3, and the other side is coming out to be negative 3. So therefore, x equals 4 is not a valid solution to this problem. So make sure you check these before you write down your answer to make sure that they work back in the original formula, because since this has to do with the fact that we're squaring both sides and properties that you will see more in intermediate algebra, so I'm not going to go into it in too much depth here, but if you would like to know the reason for this, feel free to send me an email and I'd be happy to explain. Please let me know if you have any questions.